So we've got two separate cylinders here, both fed by a 14 kilowatt Ecodan each. The symptom is intermittent hot water. So on this one first, heat pump 1, we've got heating zone 1, got domestic hot water, and if we take the cover off we can run through the logic. Worth remembering that there's some information in here, but we'll look at a better diagram in a little while. So for domestic hot water, the way this works is external time clock, domestic hot water channel. When that's switched live, it goes to that terminal there, and that opto isolator there switches and tells the heat pump that it wants to do hot water mode. That relay there then switches closed as long as the high temp cutoff is closed, and that then provides power via the live terminal down to that valve. Now we've already tested that valve wasn't working, but if we go and put the meter in continuity mode, we hear the beep, we know that it's working continuity. So with the valve closed, there is no continuity, and then when the valve motor's open, we get continuity, and that circuit would then energize the pumps. So we tested everything out. We know that the high limit stat's fine. We know that the time clock's fine. We know that the 2-port valve is fine. So the only other real thing it can be is that relay there. So with the system de-energized and giving it a tap and then re-energizing, we were able to get it to do hot water. However, given the other day I was out and observed it for an hour and a half and then no problems, but within a day or two we got a report that there was no hot water again, then that suggests that that relay is intermittently sticking. So our two options really are source the exact same relay, remove the PCB, desolder the relay and solder in a new one. However, that would require well, another 8 hours of driving really, to get that resolved that way. So what we've decided to do is, if I just grab, I have got these with me. So what we're going to do is fit an external relay, and that will close the coil of the relay based on the domestic hot water signal from the time clock, which will then close the relay and will then provide a switched live to the 2-port valve for domestic hot water. And we don't need to worry about the demand signal because that's sorted by the opto isolator. So that's the plan. So let's get to it. While that relay has been installed, it's probably worthwhile mentioning the disadvantages of using an external relay. Given replacement PCBs aren't available and refurbishing the existing PCB would be significantly more costly, we've went for a workaround, and that comes with a compromise. If using the domestic hot water switch live from the time clock to power the domestic hot water zone valve, either via an external relay as shown, or directly from the time clock itself, as I ended up doing with heat pump cylinder 2, If the time clocks are in constant on mode, the domestic hot water zone valve will also be constantly open. This would be undesirable because during heating operation you would have heat transfer from the hot water cylinder coil to the heating circuit. To get round this, I set up a twice daily hot water schedule using the time clock of each heat pump, meaning the domestic hot water zone valve will be closed outside these allowed times. Yes, it is a compromise, but these customers were quoted tens of thousands of pounds for a full replacement system. Upgrade and replacement, definitely still sensible, but at least this gives them hot water and time to make a proper plan rather than rushing into things. Thankfully I was able to find a better FTC2 or PAC IFO31 schematic on mitsubishitech.co.uk website, so that was really helpful.